Hello, welcome back on this glorious day. I'm reporting from the Izzo household. Squirrel and I are doing very, very well at social distancing. We've been watching documentaries on Netflix and on Disney Plus. We learned a great deal about the sinking of the Titanic. That was fun. Squirrel did not like the water, but is what it is. Uh, but everything's been going so far pretty good here. Fairly, I'd say it's pretty good. Squirrel says it's not good unless we have more treats, which I think that's greedy, Squirrel. Calm down. You got your treats. Okay, if you participate in this and help me out teaching advanced proofs, then you can get some treats. Yes, you have to participate. Yeah, sit in your chair and we can participate. Okay, so we did number 1 in class. Let's take a look at number 3. Number 3, we've got statement, reason, A, B, C, D is a parallelogram. Yeah, it's a parallelogram. What do you know about parallelograms, Squirrel? Nothing? You don't know a single thing about parallelograms? Well, if you're like Squirrel and you don't have any clue about parallelograms, you have to go back to the chart, take a look at it. Parallelograms, two pairs of opposite sides are parallel. Yeah, that'll give us some angles if you want angles. I would prefer to use number 2, though. I mean, you can be like Squirrel and use number 1. That's fine. I would prefer to use number 2. Number 2 is easier for me. Parallelogram has two pairs opposite sides congruent. Okay, so we've got parallelogram, definition of parallelogram, two pairs of opposite sides congruent. So that means AC is equal to BD. And it also means it says two pairs. So because we got two pairs, it also gives me AB equals CD, at which point I can say AD equals AD, reflexive, and we're done. ABD congruent to triangle DCA by side, side, side. This could have been probably one of the easiest homeworks you got for me in quite some time. That would be how you do number 3, but you have to be very clear and you have to look at parallelogram and really see what parallelogram has and what would be the most useful to you. As I say, if you wanted to go with what Squirrel did, that would be perfectly fine. You would say, okay, these two lines are parallel. Here's your transversal. That'll give you an angle here and an angle over there. So the angle up here and up here would be alternate interior angles. And then this next step would be, oh, by the way, you've got this. You could also have used the next one. The next one says two pairs of opposite angles are congruent, in which case you would get that B and C are congruent to each other, get some more angles in there. You could do this a lot of different ways. As I say, easier to just do it side, side, side. So let's take a look. I want to do number 5 with you, because number 5 is cute. ADC, so ADC is this triangle, and BCD. BCD is this triangle. Oh, we've got two triangles. They're overlapping. Got to redraw them. So ACD and CDB. From my next statement reason chart. First thing, ABCD is a rectangle. Given. Okay, rectangle. Let's take a look at rectangles. Rectangles have what? Rectangles are parallelogram. All angles equal 90 degrees and diagonals are congruent. Okay. So it's parallelogram, which means we can use anything from parallelograms. And we just used something very useful. We just used that two pairs of opposite sides are congruent. That's somewhere you might want to start. You might want to start with two pairs opposite sides congruent. Some of you are like, no, don't want to deal with that. I don't want to deal with the fact that a rectangle is a parallelogram. Even though, because we know a rectangle is a parallelogram, that gives us 6 more givens. You're just like, no, let's just stick with the pure rectangle. If you stick with a pure rectangle, you say 90-degree angles. Rectangle has 4 90-degree angles. So the 90-degree angles that we care about would be here and here. So ACD, measure angle ACD equals measure angle BDC. BDC equals 90. And then the other thing that makes a rectangle is the second piece. It means the diagonals are congruent. Rectangle diagonals are congruent. At which point you've got AD equals BC. So AD equals BC. And then if we take a look at CD, CD is a very important line. Take a look at where CD falls in the pink triangle and where it falls in the blue triangle. CD is in fact a reflexive side. So we've got CD equals CD reflexive. In which case you can do HL, because you've got angle side side, which is illegal, but that angle is a nice 90-degree angle, which makes it HL. So it's going to be HL. Be very careful. Do not forget, what do we need to do? That beautiful step right before it. Beautiful step right before it, we have to do triangle ADC is congruent to triangle BCD, not is congruent to. Triangle ADC and triangle BCD are right triangles. Are right triangles because of the 90-degree angles. All right, for this next one, what I want to do, now 5 and 6 look exactly the same, but it's trying to prove different triangles. What I want to do is I want to cross this out. We're going to cross out number 6, and I want to talk about 5 again. Now, as I said, you could do it this way, you could do HL. But there's a different way that you could do it. Statement, reason. First way that we could say is ABCD is a rectangle, and that's given. The next thing that you could do is you could just use that a rectangle is a parallelogram. So, going back to pink side and blue side, we've got pink, we've got blue, okay? So the next thing that I want to do is I want to say a rectangle is a parallelogram, and parallelograms have 2 pairs opposite sides congruent. That's going to get me this side and this side. AC equals BD, AC equals BD. Be careful though. It also gives me AB is equal to CD, but I don't want those. I do not want CD to equal AB. I want CD to just be CD. In that case, we're going to go back to the reflexive. So CD equals CD by reflexive. So CD and CD, reflexive. At that point, then you can steal this one right here. There it is. Diagonals are congruent, and you can do side, 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 which is a tiny bit better than HL. Side, 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 a little bit easier depending on who you are. Some people totally okay with HL. They can do HL, no issues. Some people would prefer to go to the side, 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 or the side angle side, or what have you. You could also steal this one up here where it says rectangles have 490-degree angles. If you got the 490-degree angles, then you got side angle side. There are a whole bunch of different ways that you can prove. As soon as you know that a quadrilateral is a rectangle, that gives you so many different givens that you can use. You can use all of these givens. You can talk about, you can even go straight with just the parallelogram and say that diagonals bisect each other. And because diagonals bisect each other, then you can add sides or add angles depending on what you're doing. There is a bunch of different things that you can do. I'm just going to end pretty flatly with rectangles have 90-degree angles. And that's going to get me measure angle ACD equals measure angle BDC equals 90. And that's going to get me side angle side because the angle is trapped. And in that way, I've got triangle ADC is congruent to triangle BCD. So there are two completely different ways that we've done this, sort of. You can sub in and out rules. Just make sure that you stick to your guidelines and you will do it right. There's a bunch of different ways. So your proof might look different from the person next to you. My proof gonna look different from Squirrel's proof. Well, because Squirrel is a kitty cat, and also because she can do it differently. She can use different from the same given that then gives us a whole bunch of different things. Now, I do want to go over number 8 because everybody gets confused with number 8. Statement reason chart, AB, and it should be ABEC. ABEC is a quadrilateral, and that's given. And I want ADC, and I want EDB. Okay. And a lot of people are like, oh, we've got angles right here. So measure angle ADC equals measure angle BDE because vertical angles are congruent. And then they're like, okay, we've got that given. We've got quadrilateral. We've got vertical angles. So let's take a look at what quadrilateral gives us. If we take a look at our notes, we've got square, rhombus, rectangle, parallelogram, trapezoids, kites. We didn't go over quadrilaterals. And there's a specific reason for that. If you take a look, quadrilaterals, 4 sides, 4 angles, angles sum to 160. Well, this is helpful, but only helpful if you're doing a maze problem. 4 sides and 4 angles is pretty much a duh. Obviously, it's got to have 4 sides and 4 angles. This is not going to be helpful at all. Just telling you it's a quadrilateral does not give you any information at all. So if you only given it's a quadrilateral, you cannot do it. Nope. All right, how are we doing on quadrilateral givens? How are we doing on using parallelograms and using our chart to figure out what that then gives us for proofs? If you're still struggling with that, definitely message me, because that is a very important task. Sometimes what we do is we take those parallelograms or those regular quadrilateral, it'll say it's just a quadrilateral and it gives us some givens. We prove it's a rectangle, and then once we've proven it's a rectangle, we've got a whole lot more givens we can use. So this is one step in many steps for some of our advanced proofs. So I want you to take a good look at that, see what you can do. I want to go on to this guy, CPCTC, corresponding properties in congruent triangles are congruent. CPCTC. Okay, so let's start our statement reason chart. And we've only got the 2 triangles, so that's exciting. Well, we've got 3 triangles because there's the big triangle, and then there's this triangle, and there's this triangle. We've got AC is perpendicular to DB. AC perpendicular to BD. That's a given. So AC and DB are perpendicular, which means we're going to get some angles. Remember, next thing we need to do, we've got this guy. The next thing has to be definition of perpendicular. And what is the definition of perpendicular? Better have some 90-degree angles involved. So DCA equals measure angle ACB equals 90 degrees. Okay, so that's our first given. Second given, measure angle B equals measure angle D. Measure angle B equals measure angle D, given. And a lot of you are already pouncing on AC equals AC reflexive. Well, that's very exciting. That means we can prove 2 triangles are congruent. But wait. What are we trying to prove? Are we trying to prove the 2 triangles are congruent? We're trying to prove that AD is congruent to AB. We're trying to prove that those 2 sides are congruent. We're not trying to prove the 2 triangles are congruent. But we can. And that's what corresponding properties in congruent triangles is all about. First step is to prove the 2 triangles are congruent. So triangle ABC is congruent to triangle. Now you have to be very careful. I did ABC. So I went from the unmarked to the marked to the right. You need to go the exact same way. So ADC. They get very finicky if you don't do that. By angle, angle, side, because the side is not trapped between my 2 angles. I got angle, angle, and then the sides up here. Now that I have proven this pink triangle is congruent to this blue triangle, I know a lot about this. What does congruent actually mean? What is the definition of congruent? Congruent, or the equals with the squiggle. What does congruent actually mean? It means corresponding sides are equal, corresponding angles are equal. So once I have proven that this is congruent, that means that I've got DC is congruent to CB. DC is congruent to CB. It means AD is congruent to AB. And I can get this other angle up here. I can say measure angle DAC is equal to measure angle BAC. And that is because corresponding parts in congruent triangles are congruent. And you have to write it all out. Now you can use the symbols. You can do corresponding parts in congruent triangles are congruent with the symbols, but you cannot simplify it to CPCTC. That is what we call the lesson, but it is not actually what you write in your proof. Now, that just gave us a whole lot of information. Do we need all that information? No. At this point, really, once we've proven the two triangles, we want AD and AB. AD and AB, done. So I did not need this step, and I did not need this step. That was just for fun. But congruent actually now turns into a vocabulary word. Do you see how perpendicular up here? We need definition of perpendicular. Now what happens is once you get two triangles congruent, that turns into a vocabulary word that gives us more information. But instead of definition of perpendicular or definition of congruent, we say corresponding parts in congruent triangles are congruent. Just like how we have that funny thing if you're doing parallel lines or circle geometry or anything that we've done this unit. Good stuff. Good stuff. All right, so let's take a quick look at number 3 on the homework. I'm going to go down to number 3. Where's number 3? Oh, fancy. Number 3. It starts with the number 3 because, you know, that's how I roll sometimes. All right, so we've got statement reason chart, just like normal. All right, here's the problem. We need to know what we want. EAB. EAB is this angle right here. Now, I'm using a bright yellow gold marker. That's probably what you want to use because we don't have the EAB is the same as EDC. We do not have that these two angles are the same, but we want to prove those two angles are the same. Now, in order to prove those two angles are the same, we could be proving that this triangle is congruent to this triangle. That would get us it. Or we could be proving that this triangle is congruent to this triangle. In this case, we want to prove that this triangle down here is congruent to this triangle up here. And the reason why I know that is because of this given. This given says AD and BC bisect each other. That means they're taking AD and BC and they're chopping them into pieces. Because they're taking the diagonals and chopping them into pieces, we are not going to be looking at this big triangle because that would be taking the diagonal and the diagonal goes straight through those two triangles. So that given wouldn't be helpful to us. So based on the given, we have to figure out which triangles we want to prove in order to find how those angles are the same. So I want to use this given, AD and BC bisect each other. Given, okay, bisect means definition of bisect. So definition of bisect, we've got AD is bisected. So that turns into AE and ED. They bisect each other. So BC is also bisected. So this turns into BE and EC. And that's the definition of bisect each other. Notice, if it were just definition of bisect, we'd have to draw our arrow and say which is being bisected. If it said BC was bisecting AD, AD would be the only thing that's being split. But in this case, it's bisecting each other. So it's bisecting both of them. Okay, so now we've got some sides. Next thing we got to do is get some angles in there, and we got some nice vertical angles going on here. Notice I cannot use this angle. That angle we do not know is congruent. That is our mission. Our mission is to prove those angles congruent. We don't have that, which is why it's not marked the same way that I normally mark it. It's marked with a bubble. I bubble in what I want to prove, and I do our regular angle marks and side marks for what I already have proved. So measure angle AEB equals measure angle CED because vertical angles are congruent. And then I can say that those two triangles are congruent by side angle side because my angle is wedged between my two sides. Notice I want, let's start at the middle. So EBA, so triangle EBA is congruent to triangle, E is my center, so it matches up with the center. Which angle matches up with B? Be careful, it's not D. Notice, our mission is to prove that A matches up with D. So if I go EBA, I have to go ECD, like this. So I've got the two triangles are congruent. Now that I have the two triangles are congruent, I can say my beautiful measure angle EAB is congruent to measure angle EDC. And the reason why those fancy sparkly gold angles are congruent is because corresponding parts in congruent triangles are congruent. All right. I know this is a very complicated process. What I want you to do is I want you to just look at question number 5. See if you can just prove two of the triangles congruent. You might be able to prove AE and EC are the same. That would be proving that AE and EC, that those two, notice I'm bubbling them in, I'm not giving them the same marks. I want to prove that those two lines are the same. Can you prove that those two line segments are the same by proving two of the triangles are the same? Good luck. See what you can do. If you are really struggling with this, don't worry. We've got another day of congruent parts and congruent triangles coming up. Tomorrow we're going to be doing more of this, and then we're going to be doing even more of this on Friday, and we're going to go back and we're going to practice some. Thank you very much. It's been a pleasure squirrel is completely gone. I have completely lost her. Have a wonderful day. Bye-bye.